Hi everyone, in this lesson we're going to look at adding and subtracting numbers that are in standard form. Let's jump into this first example. The first way we're going to do this is by converting both of the numbers that are in standard form to ordinary numbers. So here we have 4.2 multiplied by 10 to the power of 5, add 5 multiplied by 10 to the power of 4. Off to the side, let's convert both these numbers into ordinary numbers. So 4.2 multiplied by 10 to the power of 5. Well, 10 to the power of 5 is a number with 5 zeros. So 10 to the power of 5 is 100,000. And the quick way to know that is look at the index. That tells you how many zeros we've got. 4.2 multiplied by 100,000. Well, just use your common sense. 4 multiplied by 100,000 is 400,000. That means my answer is 420,000. Let's do the same thing with 5 multiplied by 10 to the 4. Well, 10 to the 4 has 4 zeros, so that's 10,000. And 5 lots of 10,000 is 50,000. We can now come over here and rewrite our calculation. 4.2 times 10 to the 5 is 420,000. And we're adding on 50,000. So we can go ahead and add these together. You might not need to set up your column addition to do this, but let me do that. So we've got this. And just make sure your place value columns are lined up. So we're adding on our 50,000 like this. Start from the right, 0 and 0 is 0, and I've got quite a few of those before I hit some numbers. Then I add 5 and 2 together to give me 7, and I've got the 4, so it's 470,000. So my answer is this, 470,000. That's the answer as an ordinary number. Of course, I could turn it into standard form. My coefficient's 4.7. Go to your largest value digit, which is in the 100,000s column. So then you know it's 10 to the power of 5. Pause the video, give this one a go by converting them into ordinary numbers. Let's go ahead and turn each of these into an ordinary number. 7.5 multiplied by 10 to the power of 4 is equal to 7.5 multiplied by 10,000. Now we know we have just over 7 lots of 10,000. Because 7 lots of 10,000 would be 70,000, that means 7.5 lots of 10,000 is 75,000. If in doubt, just replace this digit 7 where the 1 is here, and then everything else, every other digit goes to the right. And then we've got 2 multiplied by 10 to the 3, which is going to be 2 multiplied by 1,000, which is of course 2,000. The calculation I'm trying to do is 75,000 subtract 2,000. Should give you an answer of 73,000. In standard form, that would be 7.3 multiplied by 10 to the power of 4. So if you're not sure how to convert ordinary numbers into standard form, then have a look at our previous lessons where we covered that. So we've looked at large numbers, we're now going to look at small numbers. Here we have 8.3 multiplied by 10 to the negative 2, subtract 4 multiplied by 10 to the negative 3. So 8.3 multiplied by 10 to the negative 2 is equal to 8.3 multiplied by 0.01. 2 zeros here, and I knew that because the index is negative 2. Multiply these together, replace that digit 1 with the 8, and everything else will go to the right. So 0.0, and instead of the 1, I'm going to write the 8, and any other digits I had, in this case only 3, goes in here. Convert the 4 multiplied by 10 to the negative 3 into an ordinary number, and that's going to be 0.004. Then I go ahead and I rewrite this calculation. So I've got 8.3 multiplied by 10 to the negative 2. Well, that's my 0.083. And I'm taking away 0.004. Let's set up our column subtraction for that. 0.083. Take away 0.004. 3 subtract 4 I'm not able to do in its current form. So I need to exchange 100th for 10,000ths. 13 take away 4 I can do, it gives me 9. 7 take away 0 is 7. 0 take away 0 is 0. And it gives me this decimal answer, which is 0.079. If we needed to turn that into standard form, it would be 7.9 multiplied by 10 to the negative 2. Pause the video, give this one a go, and then we'll look at the solution together. So you should start by converting the 3.6 times 10 to the negative 3 to an ordinary number. That would be 0.0036. Another way to do this instead of writing out all you're working out, is to know that if I'm multiplying by 10 to the power of negative 3, I need to shift all of my digits 3 place value columns to the right because I'm making it smaller. The way I like to do it in my head is I think, okay, I've got 3.6, I need to shift it across 3 place value columns. So if I shift it across 1 place value column, that takes me to here. And then I need to shift it across 2 more place value columns. So I need to add 2 zeros. That's kind of the mental strategy that I use to do it quite quickly. Okay, and then we're adding on 5 multiplied by 10 to the negative 4. So same idea again, I've got 5, I need to shift it 4 place value columns to the right. I always go to 0.5, that's 1 place value column. I then need to go another 3, so I add in 3 zeros. And that's what my answer would be, 0.0005. Then go ahead and set up your column addition and add these together, 0.0036. And then we're adding on 0.0005. 6 and 5 is 11, take that 1 over, 1 and 3 is 4, and everything else is going to be 0. So your answer should have been 0.0041. In standard form, that's 4.1 multiplied by 10 to the negative 3. So the other way that we can add and subtract numbers in standard form is by adjusting to a common power of 10. And what I mean by that is, let's say we had 2 multiplied by 10 to the power of 31. So not really a number where we want to write that out. And we were adding on 3 multiplied by 10 to the power of 31. We can do 2 add 3 to give us 5. My answer is 5 times 10 to the 31. Now I can only do this if the powers of 10 are the same and I've got the same index. So we can go ahead and do a question like this by adjusting the powers of 10 so that they're the same. Now there are 2 ways to do it, and I'm going to show you both. The first way I would recommend doing it is by adjusting the larger power of 10 when we have a positive index. And what I mean by that is we need to take 10 to the power of 9 and we need to bring it down to 10 to the power of 6. Now we can't change the value of this number, but we can change how it's written. And what I mean by that is this. If we've got 7.3 times 10 to the 9, I can write that as 7.3 times 10 to the power of 3 times 10 to the power of 6. So I've taken 3 of my 10s, if you will, away from this, and that gives me that 10 to the power of 6, which I want. I then turn this bit into an ordinary number. So 7.3 times 10 to the power of 3, well, that's multiplying it by 1,000. It gives you 7,300 multiplied by 10 to the power of 6. I can come back up here and I've got 7,300 multiplied by 10 to the power of 6. One way to think of it is I borrowed 1,000 from the 10 to the power of 9 and brought it into the 7.3. So this number here, the 7.3 times 10 to the 9, is the same number in value as 7,300 times 10 to the power of 6, but I've just changed how it looks. I can now go ahead and take away 4 times 10 to the 6. And all I have to do here is do 7,300 take away 4. Well, that gives me 7,296 times 10 to the power of 6. This bit, the power of 10 stays the same. Then I need to convert it into standard form. So I'm going to rewrite the 7,296 in standard form. So it's 7.296 times 10 to the power of 3 multiplied by 10 to the power of 6. And my final answer would be 7.296 multiplied by 10 to the power of 9. So for that method, remember that we adjust the larger power. Let me show you the other way to do this question. And it's by adjusting my 4 times 10 to the power of 6 to be in the form of something multiplied by 10 to the power of 9. It's a little bit harder to imagine how we do that. So let's write out our 4 multiplied by 10 to the power of 6. And we want to write it in such a way where it's equal to something multiplied by 10 to the power of 9. The way that I find helpful to think about this is, if I want this number and this overall number to be equal, well, I've made this 10 to the power of 6 1,000 times larger to get it to 10 to the power of 9. So in order for these numbers to be equal, this 4 needs to be made 1,000 times smaller, which would take it to 0.004. So I do think this is a little bit conceptually harder for people to get their heads around, but if you can, then this way is absolutely fine to do. Let's rewrite our calculation. So I've got them both to the common power of 10. I've got 7.3 multiplied by 10 to the power of 9. and I'm taking away 0.004 multiplied by 10 to the power of 9. Because they've got the same power of 10, I can go ahead and subtract them. Now this method is not without its challenges. I will have to do 7.3, put down some zeros, and take away my 0.004. I put down one too many zeros there. Didn't need that one. And then I'm going to have to do some exchanging because I cannot do 0 subtract 4. So I need to borrow from here. Bring down that 1, borrow again. 10 subtract 4 is 6, 0 subtract 9 is 9, 2 subtract 0 is 2, and 7 subtract 0 is 7. And that takes me to this answer of 7.296 multiplied by 10 to the power of 9. So this way takes me to my answer a little bit quicker. It does involve a bit of a harder change or adjusting of the power of 10, and it still involves quite an awkward decimal subtraction. The first way is a little bit easier, I think, but it's up to you. Pause the video and give this one a go, and then we'll look at both ways to do it. Let's look at the first way, which is where we adjust the larger power of 10, which is this one. I'm going to rewrite this as 2.4, and I need to take 2 of my 10s, so to speak, out of it to get it to a power of 9, to get it to an index of 9, sorry. And then I've got my 4 multiplied by 10 to the power of 9 as it is. I can do 2.4 multiplied by 10 squared. So that takes me to 240 multiplied by 10 to the power of 9. And now they've got that common power of 10. I can go ahead and add them. This one's nice and straightforward. 240 add on 4 is 244 multiplied by 10 to the power of 9. To turn it into standard form, I'm going to turn this 244 into 2.44 times 10 to the power of 2 multiplied by 10 to the power of 9. And my final answer is 2.44 multiplied by 10 to the power of 11. I'll now show you the second way, which is to adjust this so it's written in a form where it's 10 to the power of 11. So I need to write 4 multiplied by 10 to the power of 9 in a form where I have some number multiplied by 10 to the power of 11. I know that to go from 10 to the power of 9 to 10 to the power of 11, I have added 2 tens, so to speak. I've not actually added tens, I've actually multiplied by 100, but hopefully you get what I mean by that. So what that means is I'm going to have to make this 100 times smaller. I'm going to have to divide by 10 squared, if you will. That takes me to 0.04. Then I can add my numbers together. I've got 2.4 multiplied by 10 to the power of 11, and I can add on my 0.04 multiplied by 10 to the power of 11. And then I can just add my 2.4 and my 0.04 together, and that gives me 2.44 multiplied by 10 to the power of 11. So a little bit quicker than our other method, but also a little bit trickier at the beginning, I think. We're now going to look at examples where we have negative powers of 10. I've got 1.25 multiplied by 10 to the negative 5, and I'm adding 3 multiplied by 10 to the negative 7. In the previous examples, we had positive indices, and in those examples, we adjusted the larger power of 10. We follow a slightly different rule when we have negative indices. My recommendation is that we adjust the smaller index. In this case, that is actually the 10 to the negative 7, because this is a smaller number than this one. So what we want to do is we want to adjust them both so they're written as 10 to the negative 5. Let's start by adjusting our 3 multiplied by 10 to the negative 7. Like before, I'm going to borrow tens from this, so to speak. I'm going to write it as 3 multiplied by 10 to the negative 2 multiplied by 10 to the negative 5. So hopefully you see how I've borrowed 2 tens from the 10 to the negative 7. Like I said before, we're not actually taking away tens, we're just rewriting our calculation. Then do 3 multiplied by 10 to the negative 2. Well, that gives you 0.03 multiplied by 10 to the negative 5. So I've now adjusted it so that they both got that 10 to the negative 5. We can now go to our calculation. I've got 1.25 multiplied by 10 to the negative 5. And I'm adding on 0.03 multiplied by 10 to the negative 5. Go ahead and add your coefficients. So 1.25 add 0.03. 5 and 3 is 8, and that gives me 2 there and a 1 there. So my answer is 1.28 multiplied by 10 to the negative 5. That's the method I would recommend for this one. I've got 6.7 multiplied by 10 to the negative 8, and I'm taking away 3 multiplied by 10 to the negative 9. We're going to adjust the 3 multiplied by 10 to the negative 9 because that is actually the smaller number. And we want to bring it down so it's written as 10 to the power of negative 8. So off to the side, I'll write 3 multiplied by 10 to the negative 9. I'll take one of my 10 to the negative ones and rewrite it as 3 multiplied by 10 to the negative 1 multiplied by 10 to the negative 8. Then we go ahead and tidy this up. 3 multiplied by 10 to the negative 1 is 0.3 multiplied by 10 to the negative 8. I can now come back to my calculation. I have 6.7 multiplied by 10 to the negative 8, and I'm taking away 0.3 multiplied by 10 to the negative 8. Go ahead and subtract your coefficients now that we have our common power of 10. 6.7 subtract 0.3. 7 subtract 3 is 4. 6 subtract 0 is 6. So my final answer to this is 6.4 multiplied by 10 to the negative 8. If you're using our lesson booklets, please now complete exercises 1 to 3.